Alright, this is section 8.5 on building linear equations. This is a pretty long section. It will probably be broken into a couple of videos. It's a lot of algebra, a lot of equation manipulation, so you might want some extra paper with you, just in case you run out of room. We're also going to be using point-slope form a lot, which a lot of students struggle with at first. It's just kind of a weird formula. So you need to just remember the structure of point-slope form. And I'll show you kind of an empty template for point-slope form, which helps some students plug in the values. So we're going to work with this a lot throughout this section, and hopefully you'll get used to it as we go along. But I want to make a little flashcard for yourself just to have it out handy to remember that formula. And then again, maybe some extra paper for this one. You might want your calculator handy if the numbers get a little big, but I think they're all pretty reasonable. So before we start using point-slope form, the first thing we want to be really good at is changing forms of linear equations. Remember, there's three forms that we're working with. There's standard form, there's slope-intercept form, which is the one we're most comfortable with usually, and there's also point-slope form, which is the one you don't work with quite as much, and students get that one a little mixed up. So you always want to be able to have all three forms. You can change. The most common thing to be able to do, or the most valuable thing to be able to do, is to switch from standard form to slope-intercept and slope-intercept back to standard. So it's a good skill to have to switch back and forth. So that's what we're going to practice first. You might not need extra paper for this. It just depends on how big you write. So we're going to rewrite the following from standard form, which is the form they're in now, to slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So we're basically solving for y, which we did practice in a previous section. So really on each one of these we want to solve for y. And being able to do that just makes our lives easier when we get into the more complicated problems. So here we're going to move that 3x to the other side. That's going to give us y equals negative 3, that should be an x, plus 9. And sometimes you have to divide by the coefficient on y, but here we do not. We're just done. So we've changed that from standard form into slope-intercept form. The next one's a little bit more involved. Notice here that 2x is negative, so we're going to add 2x to both sides. That's going to give us 5y equals 2x minus 14. Then we're going to divide everybody by 5. And I'm going to rewrite that over here. That's going to give us y equals 2/5 x. So just kind of take your coefficient and what you divided by. Sometimes that divides nicely, sometimes it doesn't. Minus, and then this sometimes divides, sometimes it doesn't. We'll just leave it 14 over 5. If it can reduce, go ahead and reduce it. Otherwise, you can just leave it like that. Then on the next one, same idea. Let's move the x to the other side. That's going to give us negative 2y equals negative x plus 8. And then from there, we'll divide everybody by negative 2. This is a 1, if it helps to put the 1 there. So I'm going to write it again over here. So we have y equals, those cancel. Negative divided by negative cancels out, and then 1 over 2. So we have positive 1 over 2x. And then positive 8 divided by negative 2 would be negative 4. So just practicing rewriting them into slope-intercept form, which we've done before and is not too bad. You just solve for y. Going back the other direction is a little bit more challenging, going from slope-intercept form into standard form. The reason you would need to do this is if the instructions want the final result in standard form. So a lot of the times getting things into slope-intercept form is pretty easy, but then having to switch back to standard form is a little bit more challenging. Remember, standard form is ax plus by equals c. And it's a little bit more particular in its conditions. And so for this, a, b, and c must be integers, which means no fractions, no decimals. And there's another specification. Some textbooks honor this, some do not. I think ours does. That A, the leading coefficient needs to be greater than 0. It needs to be positive. And so that's usually a condition for standard form. All three of the coefficients need to be integers, and the leading coefficient needs to be positive. Alright, so that makes these a little bit more challenging to do. So up here we move the x term to the right, and now we're going to move the x term back to the left. So the first thing we want to do is move that 4x back to the left. I'm going to work sideways here. That's going to give us negative 4x plus y equals negative 2. So we just move that 4x to the other side. It goes away here. It comes on over here. And then the other thing you have to check these two conditions. Make sure these are all integers, which they are, and that the leading coefficient is positive, which right now it is not positive. So you might want to take a different color, pen or pencil, whatever you have. And we're going to multiply this whole equation by something that will make this negative go away. You can multiply by whatever you want. The easiest thing to multiply by is negative 1. If I multiply every term by negative 1 on both sides of the equation, the negatives will cancel out here, and I'll have a positive leading coefficient. You could multiply by 2 or 3 or some other number, but the easiest number would be 1. All that does is change your signs for you. So it's going to give us positive 4x. The negative 1 is going to multiply with the positive. Again, there's a 1 here. So it's going to be negative y equals, and then positive 2. So all the signs will change. So this is the proper standard form. All the coefficients are integers, and the leading coefficient is positive. So let's look at the next one here. This one's a little bit trickier. 1/2 is your coefficient. So just like we did here when we subtracted 4x, we're going to subtract 1/2 x, which does look a little strange, but that's what we do. That's going to give us negative 1/2 x plus y equals negative 5. From here we have two problems. The leading coefficient is not an integer, and it's negative. So we can fix both of those problems at the same time. We know if we multiply by a negative, it will fix the negative. And then if we multiply by the denominator, it will kill the fraction. So you might want to make a note of that. Multiply by the denominator, and you might have seen this back in chapter 2, to eliminate the fraction. Multiply by the denominator to eliminate the fraction. And that works in any situation, any algebra equation that you're in. If you need to get rid of that fraction, you multiply everybody by the denominator. Alright, so if I multiply everybody by negative 2, distribute, 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 let's see what's going to happen. These 2's are going to cancel. These negatives are going to cancel. So you're just going to be left with 1x. If this was a 2, you'd be left with 2x. If this was a 3, you'd be left with 3x. So whatever that numerator is, that's what you're left with. The negative 2 is going to multiply by the positive y to make negative 2y. And then the negative 2 is going to multiply by the negative 5 to make positive 10. Now you have all integer coefficients, and the leading coefficient is positive. So like I said, that's a little tricky to work with at first, but you'll get used to it as you practice. And we'll see this over and over throughout this section. Alright, let's look at the third example here. We have negative 3/4 for the coefficient, and so we're going to add 3/4 x to both sides. That's going to give us 3/4 x plus y equals 7. All the coefficients are positive. The leading coefficient is positive, but it's not an integer. So we're going to take the whole equation, and again, a different color is helpful here. We're going to take the whole equation and multiply by the denominator. Whatever the denominator is of the fraction, the whole equation gets multiplied by that. And everybody gets multiplied by 4. For this one, this 4 and this 4 cancel out. So we're just left with 3x Then it's 4 times y, so plus 4y. And then 4 times 7 is 28. Now everybody's an integer, and the leading coefficient is positive. If you'd like to try the last one on your own and then play the video back, you can pause and play the video back to make sure you got it right. Let's see here. We're going to move 3/2 x to the other side. So we're going to have negative 3/2 x plus y equals 5. We need to fix the negative and the fraction. So we're going to multiply by a negative to fix the negative, and we're going to multiply by the denominator to fix the fraction. And then everybody gets affected by that change. So the negatives cancel, the 2's cancel, so we're just left with 3x. Then negative 2 times y would be minus 2y, and negative 2 times 5 would be negative 10. So it's a little bit more involved to go from slope-intercept to standard, but sometimes in the instructions it will ask for the final equation in standard form, so we'll have to use this technique. And sometimes we're given something in standard form and we need it in slope-intercept form, so it's a skill. Both skills are handy depending on the problem and what you need to do with it. So now that we're good at switching forms, let's talk about building equations. This is the toughest part of this chapter, is building these equations. Again, we're going to use point-slope form, which I typed out here for you, and you might want to have a flashcard handy just to really get used to it. Anytime you're waiting in line for something or waiting at the doctor, you might just want to look this over and make sure you've got the structure down. So building equations can be a variety of different things. I'm going to show you several different examples. These problems take the longest amount of time, and again, you might need some extra paper depending on how big you write. So we'll go through a few of these. If you think you're getting the hang of it, you're always welcome to pause the video and try on your own, and then play it back and see how you do. So let's look at example 1. It says, write an equation of a line with a slope of 3 through the point 62 in standard form. So this is going to be your final form. Sometimes I call it the finished form. So it's kind of like when you write a paper. You have a rough draft, and then you have your final copy. And so point slope form is kind of your rough draft. It's kind of where you start your blueprint or your outline. And then we maneuver things around and get it into the finished form, which is standard form. But you always start with your rough draft. You start with point slope form, and then you finish in whatever form it specifies. So many times students are trying to force standard form from the beginning, and it just doesn't work. We have to start here and use this to get into standard form. So we have a slope and we have a point. We know the slope is m, and the point is x1, y1. So in point slope form, we're going to plug in y1, we're going to plug in x1, and we're going to plug in m. So I like to start with that empty structure. Y minus box equals blank times x minus box. So I like to start there, and then I'll fill it in with the numbers I have. So m is 3, x1 goes with x, which is 6, and y1 goes with y, which is 2. So I fill in what I have, and again, different colors can help so you can really see your structure. And from there, I clean it up. So I'm going to distribute my 3. That's going to give me y minus 2 equals 3x minus 18. And I always move my constant to the right, because in either form you have to have your constant to the right. So from there I'm going to add 2 to both sides. That's going to give me y equals 3x minus 16. From there I have to go back to the original instructions and see what form it wants. It wants the final answer in standard form. Right now we're in slope-intercept form, which is typically what form you end up with. But we always have to get ourselves back to whatever form it wants, which is standard form. So we're going to move that 3x back to the other side. That's going to give us negative 3x, oops, negative 3x plus y equals negative 16. And then we have to fix that leading coefficient by multiplying by negative 1 for a final answer of, sorry, I got a little messy. It's going to be 3x minus y equals positive 16. So all the signs are going to change. So we start in point-slope form. We work out the details until we get into slope-intercept form. Then we go back and read what form it wants it in. Sometimes it wants slope-intercept form, so you're done. Sometimes it wants standard form, so you have to convert it into standard form. So it's kind of a process. Each step is pretty simple, but you just have to keep up with what part of the procedure you're on. Let's look at another example of that. Write the equation of a line with a slope of negative 2/3 through the point 2, 7 in slope-intercept form. Again, this is your finished form. This is your final copy. We always start with our rough draft. So I like to start with that empty structure. Y minus box equals blank times x minus box. Fill in what I have. Let's see, our slope is negative 2/3. x1 is negative 2 and y1 is 7. So this one's a little bit more complicated. We have y minus 7 equals negative 2/3 times x. It's minus negative 2, so we're going to go ahead and just change that to plus 2. From here, a lot of students don't like the slope being a fraction. It makes it harder to work with. So if you want to, and I do recommend this, we can multiply both sides by the denominator 3 to do what we call kill the fraction. I know that's a little harsh, but it kind of just makes our lives a little bit easier if we can get rid of that fraction. Now the 3 on the right just cancels with the denominator. Nothing else changes on the right. On the left, we actually distribute through with that 3. Technically, you don't have to do this step, but it makes your life so much easier not having to work with that negative 2/3. So that gives us 3y minus 21 equals negative 2 times x plus 2. If you want to, if you're comfortable, you can distribute right from there, or you can distribute here. Just depends on your comfort level. And that should give us 3y minus 21 equals negative 2x minus 4. I'm running out of room. From here, we want to move that constant to the right. And that's going to give us 3y equals negative 2x. Negative 4 plus 21 will be plus 17. From here, we want to go back and read what form they want it in. They want it in slope-intercept form, so I'll divide everybody by 3. If they want it in standard form, you can move the 2x to the other side. So you have to go back and read the instructions into what final form they want. So I'm going to add 2x. No, I'm not. That would be if we want standard form, sorry. Just testing you right there. So instead of moving the 2x, we want in slope-intercept form, so I'm going to divide everybody by 3. So y equals negative 2/3 x, and this will just stay a fraction plus 17 over 3. We don't have to graph these, so it's okay if it's not a pretty number. So there's your final form in slope-intercept form. I'm going to go ahead and stop there. You can go ahead and keep working the examples. I'll record a separate video with more of these examples worked out, but I'm going to pause there so the video is not too long.